A Tudor warship sank nearly 500 years ago. The bones of its crew reveal what life was like. Well-preserved bones recovered from an English shipwreck are shedding light on what life was like for the crew of the ill-fated Mary Rose, and offering surprising insights about changes in bone chemistry that could benefit modern medical research. The Mary Rose was one of the largest warships of the Tudor Navy during King Henry VIII's reign until it sank on July 19, 1545, during a battle against the French. Hundreds of men were trapped on board when the ship sank in the Solent, a strait between the Isle of Wight and mainland Great Britain. In 1982, the hull of the ship, its artifacts and the bones of 179 crew members were excavated from the Solent and brought to the surface. The hull and its collection of 19,000 items are on display at the Mary Rose Museum in Portsmouth, England, and research is underway on the remains to uncover aspects of the identities and lifestyles of the crew members. Researchers have analyzed the collarbones from 12 men between the ages of 13 and 40 who died on the Mary Rose to see how their tasks on the ship may have shaped the chemistry of their bones. The team also looked for telltale signs of aging and evidence of hand deadness, or which hand the crew members naturally favored. The results of the study were published Wednesday in the journal PLOS1, and the findings could contribute to a better understanding of age-related changes in our bones. Advancing our knowledge of bone chemistry is crucial for understanding how our skeletons age and how medical conditions affect the bones, said lead study author Dr. Shiona Shankland, a research associate at the Lancaster Medical School at the UK's Lancaster University. Understanding these changes could allow us to be more informed about fracture risk and on the causes of conditions like osteoporosis and osteoarthritis, which are commonly experienced with aging. The enduring mystique of the Mary Rose. In 1510, 1 year after ascending the throne, Henry VIII signed off on a request for 2 new ships to be added to the royal fleet. The Mary Rose was one of them, and the flagship became the king's favorite. The ship saw action against the French in Brest, France in 1512, and succumbed in its final battle during a large invasion by the French fleet in 1545. Despite the wealth of research conducted since the ship's recovery, questions remain about what caused the vessel to sink. Regardless of the cause, she rolled onto her starboard side and water entered through the open gun ports, said study co-author Dr. Alex Hildred, head of research and curator of ordnance at the Mary Rose Museum. With few access points between decks and a heavy net spread across the open upper deck, the 500 men were trapped on board, Hildred said. Those stationed on the uppermost decks within the bow and stern castles, or in the rigging, were the only survivors. Hildred helped supervise the underwater excavation, including recovering the largest concentration of human remains from the wreck, and she has facilitated research about the bones ever since. Despite being underwater for hundreds of years, the remains were remarkably well preserved because a layer of sediment that settled over the ship created an oxygen-free environment, said Shankland, who will begin as a lecturer at the University of Glasgow in Scotland in November. The nature of this environment means the remains of the sailors have not degraded the same way that would be expected in most archaeological discoveries, allowing us to reliably investigate the bone chemistry, she said. Favoring the right hand, Shankland was interested in the idea of studying clavicles, or collarbones, from the shipwreck because the bones showcase unique characteristics related to age, development, and growth. The S-shaped bones are some of the first to form in the human body, but the last to fuse fully, typically between ages 22 to 25 in humans. They play a critical role in attaching upper limbs to the body, and clavicles are some of the most commonly fractured bones, said study co-author Dr. Adam Taylor, director of the Clinical Anatomy Learning Center and professor in anatomy at Lancaster University. The research team used Raman spectroscopy, a non-destructive method that preserves valuable samples, to study the bones, Shankland said. The method involves using light to uncover the chemistry of a sample. The team analyzed how light reacted with molecules within the bones, and changes in the color of the light allowed the researchers to identify specific substances. Bones are composed of a balance of minerals and proteins. The minerals provide bones with resistance, strength, and rigidity, while protein gives them flexibility and resistance to fracture, Shankland said. The analysis showed that the balance of protein and minerals changes with aging. The mineral content of the bones increases with age, and protein content decreases. The changes were most noticeable in the right collarbones, indicating that the crew members favored their right hands, but they may not have had a choice, as individuals from this time would have been forced to be right-handed. As left-handedness had negative associations in medieval England, we could assume this difference in the right side was due to hand-deadness, Shanklin said by email. At the time, left-handedness was associated with witchcraft, so crew members would have relied on their right hands and put more stress on their right sides during repetitive tasks on the ship, Shanklin said. Understanding the relationship between hand-deadness and impacts to the clavicle is crucial. When people fall, they usually put out their dominant hand to break the fall, which is one of the most common ways to fracture the clavicle, Shanklin said. This suggests that hand-deadness influences clavicle bone chemistry, offering an important modern consideration for fracture risk, Shanklin said. These results enhance our understanding of the lives of Tudor sailors, but also contribute to modern scientific investigation in the drive for a clearer understanding of changes in bone chemistry and potential links to aging-related skeletal diseases, such as osteoarthritis. The study provides a new facet of information about the crew members of the Mary Rose and how their occupations in Tudor England shaped their bodies and bones, said Richard Madgwick, a professor in the School of History, Archaeology, and Religion at the UK's Cardiff University. Madgwick was not involved in the current study, but previously researched other aspects of the remains. Biomechanical aspects of these strenuous, repeated tasks have long been understood, but the chemical variation and contrasting changes in mineral and protein components are much more poorly understood, Madgwick said by email. The study has ramifications well beyond the Mary Rose. Its novel, high-resolution method provides a new approach for gaining insights into human lifeways, occupations, and the stresses endured in the past, crucially, without any destruction of the invaluable archaeological remains. New revelations. Each time researchers study the remains of the crew, they glean new insights, such as the diverse backgrounds of some of the crew members. The fact that this research has tangible benefits today, nearly 500 years after the ship sank, is both remarkable and humbling, Hildred said. Next, Shanklin wants to study the remains of the archers aboard the ship to see whether their spines bear any of the signs of the unique motions they performed. The archers used long bows, which required a huge amount of rotation of the spine when pulling back on the bowstring. This means one side of the spine is under more repeated stress in a predictable motion, so the changes across the spine wouldn't be symmetrical, Shanklin said. Investigating the impact of this on the spine would further our understanding of bone chemistry changes with age, but also with stress from activity,